And so number 4 is really something. And so if we look at our 3 different denominators that we've got v squared plus 8v plus 15. We've got v plus 3. And we've got v plus 5. Now, if we were to go to the work of factoring the first one, we would be looking for factors of 15 that make 8. That would be 5 and 3. And we would end up with v plus 3 times v plus 5 as our factored form of that quadratic. And we will notice that it's fortuitous, and I hope that if you are doing these problems on ALEKS that the same thing happens. That in factored form matches what our 2 other denominators are. So our common denominator is going to be v plus 3 times v plus 5, and that covers all of the different factors there. So I wrote that up high because it is going to be taking a lot of work to do this problem, and I'm going to need the space. So first of all, I will say I'm sorry about number 4 because it's pretty rough. And so with that, let's get going. So we're going to multiply everything again by v plus 3 times v plus 5. And I'm going to leave that in factored form because it will help me later when I go to do the canceling. And so that gets multiplied by 2 over v squared plus 8v plus 15. And that is equal to 1 over v plus 3 minus 4 over v plus 5. And so this denominator right here, I want to factor that right now. It will just help me as we go ahead. So v plus 3 times v plus 5 over 1 times 2. And remember, if we factored that, we would get v plus 3 times v plus 5 equals 1 over v plus 3 minus 4 over v plus 5. And so we do our multiplication. We get 2 times v plus 3 times v plus 5 over v plus 3 times v plus 5 is equal to, oh shoot, I forgot to write the multiplication piece out on the right side there. So let's take care of that. We've got to have v plus 3 times v plus 5 over 1 times both of the terms on the right, 1 over v plus 3, and then a minus v plus 3 times v plus 5 over 1 times 4 over v plus 5. Super nasty looking thing. All right, so v plus 3 times v plus 5 times 1 is v plus 3 times v plus 5 over v plus 3. And we've got a minus 4 times v plus 3 times v plus 5 over v plus 5. Wowzer. So these v plus 5s are going to cancel each other out, and these v plus 3s are going to cancel each other out, and these v plus 5s are going to cancel each other out. So will these v plus 3s. I know that some of my v's look like u's. Please don't let that confuse you. They're all v's. And so now on the left side, we have 2 is equal to v plus 5 minus 4 times v plus 3. Just going to look at my previous work and make sure I'm agreeing with myself here. It looks like that way. So now we can simplify the right side. The fractions are gone. The reason the fractions are gone again is because we multiplied everything by a common denominator. And so we will have 2 is equal to v plus 5 minus 4v plus, minus 12. That negative 4 stays with The negative stays with the 4, and so we get a minus 12. Almost made a mistake. Okay, simplify the right side further. Positive v and negative 4v makes negative 3v. Positive 5 and negative 12 makes negative 7. And so we've got to add 7. It gives us 9 is equal to negative 3v. We divide by negative 3. And we get negative 3 is equal to v. Now it's important, as we've mentioned in previous ones, to check and see if that is a viable solution. And in this case, that is not a viable solution, because if I put negative 3 in that denominator, it would make 0 in the denominator, and we can't have that. So in the case of this one, there is no solution. Because negative 3 would cause there to be a 0 in a denominator. And we can't have that. So that's it for number 4. Kind of a gnarly one. But again, as always, I hope this is helpful.